Hi guys, welcome to Learn with Kani YouTube channel. This channel is all about learning concepts and solving problematic questions related to civil engineering. So please support me by subscribing to my channel so that whenever I upload a new video, you get notification and you won't miss out to watch my video. So today in this video we are going to see how to solve problem related to strain energy due to torsion. So in previous video I have explained about what is strain, types of strain, what is strain energy and what are the problems involved in strain energy, and we have solved a problem related to strain energy due to bending. So I will give you that video link in description box so that you can watch to know about it. Now moving on to today's topic. Today's topic is about strain energy in torsion. Generally, what is strain energy? Strain energy is basically defined as the internal energy stored in the body when body is subjected with a load within its elastic limit. We must have to ensure that load applied over the body must be within its elastic limit. That is, after removal of load, body must secure its original dimension. So, strain energy in torsion. Here I have drawn a solid circular shaft. So consider a solid circular shaft of length L and radius R. Here I have drawn a solid circular shaft with length L. I have denoted here, and then radius R I have mentioned there from that point to the end. That is radius, and then subjected to a torque T, producing a twist theta in the length of the shaft. So here I have drawn a torque at both sides because it will act at both sides, and then due to this an angle will form, that is the twisting angle, that is theta, in the length of the shaft. Along with the length of the shaft, this torque produces a twist, and this twist forms an angle, that is theta. Now the work done is equal to half into T into theta, which is stored in the shaft as strain energy. Generally, torsional energy or strain energy is equal to the work done by the torque, which is equal to average torque into angular twist. So, strain energy per unit is generally 1/4 the ratio of square of shear stress to modulus of rigidity. And then that only I have shown here. Next, but torsional equation is T by J is equal to tau by R is equal to C theta by L. First, let us learn the full form of each of the terms. T is nothing but torque applied and its unit is Newton meter. And then J is nothing but polar moment of inertia, and tau is nothing but shear stress on the surface of the shaft. It is with the unit Newton per meter square. Then R is nothing but radial distance of point from center of section, and it is with the unit meter. As it is distance, it will be in meter only. Then C is nothing but modulus of rigidity or radius of cross section, and its unit is Newton per meter square. And then theta is nothing but the angle of twist, and then L, which is nothing but the length of the bar or shaft, it is with the unit meter. And then IC is equal to pi d power 4 by 64 if the bar is used as a beam. If that bar is used as a beam, then we should use the formula pi d power 4 by 64. Okay, and then if the bar is used as shaft, then we have to use J is equal to pi d power 4 divided by 32 if the bar is used as shaft. Then formulas to be used for strain energy in torsion. In this, when the shaft is solid, U is equal to tau square divided by 4C into V, where U is nothing but the strain energy, tau is nothing but the shear stress with the unit Newton per meter square, and then C is nothing but modulus of rigidity, and then V is nothing but it's the volume. Then when the shaft is hollow, I have drawn there a solid thing. Here, if in case the shaft is hollow, we have to use the formula U is equal to tau square divided by 4C into open the bracket d square, that is capital D square plus small d square divided by d square, capital D square into V. And then here the capital D is nothing but 2 times the radius. We know obviously diameter is 2 times the radius. And then where U is nothing but the strain energy, tau is the shear stress, C is the modulus of rigidity, and capital D is nothing but external diameter of the bar or shaft, and then D, small d is nothing but the internal diameter of the bar or shaft, and then V is nothing but it's the volume. Now power transmitted by a circular shaft. For this we need to use the formula, which is nothing but P is equal to 2 pi nt by 60. That is the formula we have to use for power. Okay, so P is equal to 2 pi nt by 60, where P is nothing but the power which is with the unit kilowatts, and then N is nothing but the number of rotations which is calculated in RPM, and then T is nothing but the torque or twisting moment, and it is with the unit kilonewton meter. That is the unit for torque. Now moving on to the question. It is an important university question. So the external diameter of a hollow shaft is twice the internal diameter. It is subjected to a pure torque and it attains a maximum shear stress tau. Show that the strain energy stored per unit volume of the shaft is 5 tau square divided by 16C. Such a shaft is required to transmit 5400 kilowatt at 110 rpm with uniform torque. The maximum stress not exceeding 84 meganewton per meter square. Determine first one the shaft diameter, second one the energy stored per meter cube. Take C is equal to 90 giganewton per meter square. Now moving on to the solution. First I am writing the given data here. So given data. In the question they have said as that show that the strain energy stored per unit volume of the shaft is 5 tau square divided by 16C. So strain energy is denoted with the symbol U. So divided by per unit volume they have mentioned. So divided by unit volume of the shaft is 5 tau square by 16C. So I am just writing what they have given in the question. I am just writing the given data here. Now such a shaft is required to transmit 5400 kilowatt. So they have given here the power. So power P is equal to 5400 kilowatts. Now at 110 rpm, we know very well that rpm is nothing but n. It is denoted with n. So n is equal to 110 rpm. And then now the maximum stress not exceeding 84 meganewton per meter square. We know that stress is denoted with the symbol tau. Maximum stress, so tau max is equal to 84 meganewton per meter square. Here this is with the unit meganewton per meter square. So now we are going to convert it into newton per mm square for easy calculation purpose. So we know that 1 meganewton is equal to 10 power 6 newton and 1 meter is equal to 10 power 3 mm. Just doing a simple thing to convert from meganewton and meter to newton and mm square. I am just writing 84 into 10 power 6 divided by meter square, so 10 power 3 the whole square, which is nothing but 10 power 6. So cancelling both, it will be 84 newton per mm square. So tau max is equal to 84 newton per mm square. We are just converting this mainly for the purpose of unit purpose only. So tau max is equal to 84 newton per mm square. Now power is equal to 5400 kilowatt. We have to convert this into watts. So 5400 into 10 power 3 watts. How did I write this? It is nothing but 1 kilowatt is equal to 1000 watts. So just applying this for conversion purpose, I am just writing there. So 5400 into 10 power 3 watts. Now in the question they have asked us to determine the shaft diameter. So the first part is the shaft diameter determination. For this we are going to use the formula power. So P is equal to 2 pi nt divided by 60. We are using this formula because they have given the power value and then n value, and we need to find, when we find this t, with that we can go with the torsional equation, and with the torsional equation we can find the diameter. That is the logic here. So to determine t we are using this power formula, as they have given even the values related to power and number of speed, that is n. So just rearranging this, t is equal to p into 60 divided by 2 into pi into n. So value of p is 5400 into 10 power 3 into 60 divided by 2 into pi into n. N is nothing but 110. So I'm just showing how to do this in the calculator. First give double bracket and then 5400 into 10 power 3, close the bracket, then into, open the bracket, 60, then close it, then close the overall bracket, then divided by, open the bracket, 2 into pi. We are just going to substitute pi as pi itself, not by 3.14. So just giving shift and exp, we will get the pi symbol, and then into 110 and closing the bracket. So the value is 4 6 8 7 8 3. I am just leaving after the point value, so it is just 468783 Newton meter, as torque unit is Newton meter. I'm just writing that. So T is equal to 468783 Newton meter. So into 10 power 3 Newton mm, for just a conversion purpose. So I'm just converting meter into mm. Now to determine T, that is the diameter, by using torsional equation, as we have found the value of torque by using the power, now we are using torsional equation to find the value of D. See how I am doing that? By using torsional equation, generally torsional equation is T by J is equal to tau by R is equal to C theta divided by L. This is the general equation. Now T by J is equal to tau by R. This is the required part, because we know these values only. We don't know about C theta by L. We don't know anything related to that. So just ignoring that and doing with this equation, T is equal to J into tau by R, where we know that J is equal to pi d power 4 divided by 32. Why did I write this? Because if the bar is used as shaft, we need to use this formula only, as I mentioned earlier. In the question they have given that it is a shaft, so we are using J is equal to pi d power 4 by 32. So T is equal to pi divided by 32 into d power 4. Here in the question they have clearly mentioned that it is a hollow shaft. So capital D power 4 minus small d power 4 into tau divided by r is nothing but d by 2, because d is 2r, so r is nothing but d by 2. I am just writing that here, r is equal to d by 2. Radius is nothing but half of the diameter, right? So it is just simple thing. Now which is equal to pi by 32 into d power 4 minus this small d power 4. We need to note in the question that the external diameter of a hollow shaft is twice the internal diameter. So the capital D is twice the internal diameter. The external diameter is twice the internal diameter. We need to substitute the small d with d, capital D by 2, because capital D is 2 times the small d. So writing that here, in place of small d, capital D by 2 the whole power 4, closing the bracket. Now I am taking that d part which is outside, that is the tau by d, that capital D inside into this bracket. So divided by capital D into tau, just moving that d, capital D inside. It is just a simple max only. So pi by 16 into, open the bracket, d power 4 minus d power 4 divided by 2 power 4 is nothing but 16 divided by capital D, closing the bracket, into tau. Now which is equal to pi by 16, open the bracket, just doing a simple max thing, that is just multiplying and dividing 16 into d power 4 minus d power 4 divided by 16, the whole divided by capital D into tau. So which is equal to pi by 16 into 16 d power 4 minus d power 4 is nothing but 15 d power 4 divided by 16, close the bracket, whole divided by capital D, close the bracket, into tau, which is equal to pi by 16, open the bracket, 15 d power 4 divided by 16 into, this d is nothing but d by 1 generally, so I am just making it inverse, so into 1 by d into tau, pi by 16 which is equal to pi by 16 into 15 d power 4 divided by 16 into d, 16d. Okay, into tau. Now cancelling d, so it is d cube, so pi by 16, open the bracket, 15 capital D cube divided by 16 into tau, which is equal to pi into 15 d into capital D cube into tau divided by, just multiplying all the thing and dividing it with 16 into 16, which is nothing but 256. Now this is nothing but t is equal to j into tau by r. So in the place of left hand side it will be t, capital T, which is equal to pi into 15 into d cube into tau divided by 256. This t already we have calculated from the power formula. So 468,783 into 10 power 3, which is equal to pi into 15 into d cube into tau max, because in the question they have given tau max only, so we are just using tau max divided by 256. We know that in the question they have given it is 84. So just substituting that here, just rearranging d cube in one side and keeping and just moving all other in other side, that is 468783 into 10 power 3 into 256, because I am just keeping d cube at one side, right? So it's just a simple max to do this. So divided by pi into 15 into tau max is nothing but 84. So now let me show how to do this in the calculator. I will just do that in the calculator. First, open double bracket and then 46783 into 10 power 3, close the bracket, into open the bracket 256, close the bracket and close the double bracket, divided by open the bracket. I am just giving pi as pi itself, so pi into 15 into 84, close the bracket. So the value is see here in the calculator, it is d cube is equal to 3031736.45, 361.45. So d is nothing but cube root of 3031736.45. I am just doing that in the calculator and I will show the value of d now. See, cube root of the answer, that is, it is nothing but 311.81. So diameter is 311.8 mm. So we have found the shaft diameter, that is 311.8 mm. This is the answer for the shaft diameter, that is the external diameter. Okay. Now the internal diameter is capital D by 2. So 311.8 divided by 2, which is nothing but, I will just do it in the calculator, 311.8 divided by 2. See, it is 155.9. That is the internal diameter. So from this we have arrived the external diameter and internal diameter of the shaft. So first part is over. Now moving on to the second part. In the second part they have given that the energy stored per meter cube. So energy is nothing but the strain energy per meter cube. Meter cube means it is the volume only, so U by volume. In the question already they have given that strain energy per unit volume is 5 tau square by 16 C. Now we are just going to calculate that stored energy per unit volume value. So U divided by volume is equal to 5 divided by 16 into tau square divided by C. Just keeping constants at one side, I am just doing that. So 5 by 16 into tau square. Tau is nothing but the shear stress. Already we know the value of tau max, that is 84. So 84 the whole square divided by, so 90 into 10 power 3, that is the value they have given for C. It is given in the question, which is nothing but C is equal to 90 into 10 power 3. 10 power 3 I am just using that because 1 giganewton is 10 power 3 Newton. Just a unit conversion. Now calculating this in the calculator, I will just show that to see. I'm just showing how to do this calculation in the calculator. So open double bracket 5 divided by 16, close the bracket, into open triple bracket and then 84 close the bracket, whole square, close the bracket. So I have completed that part, and then divided by, open the bracket, 90 into 10 power 3, and then close the bracket, close the overall bracket. So the value is, what we have arrived is 0.0245. I hope it is clear. So the answer is 0.0245 Newton mm. Here I am just moving the 3 decimal point at right side, and moreover I am converting mm to meter, that is into 10 power minus 3. So overall it will be like 24.5 into 10 power minus 6 Newton meter. Finally we have arrived the energy stored per meter cube. This is the value for the question. So this is the end part of this question 2. Finally we have arrived at the shaft diameter, that is the internal diameter, external diameter, and energy stored per unit volume. This is the end of the solution. I hope it is useful for you. So thank you for watching this video. For more videos, subscribe Learn with Kanni YouTube channel, and don't forget to like, share and comment. Once again, thank you and take care.